Ian, we're here inside your Fibonacci house, having you on the podcast for the third time. It's a beautiful thing.
Yeah, you like boring your viewers, eh?
Well,
going back to the well of repetitiveness, or what?
Sometimes I think the people who I talk to the first time say things more similarly than somebody who I speak to the second time, or even we'll see what happens on the third time. Ideally, we've already discussed some of the more boring surface level things, and we can dive into maybe some hard-hitting questions.
Sure. Yeah.
I think the first.
Do I get to hit back just as hard?
Absolutely.
As
Please.
All right.
Harder, hopefully. First one. You started this company how many years ago?
2018, we incorporated in the Netherlands. The Canadian subsidiary about a year after that. The German subsidiary around that same time. So yeah.
From the day we spent together today and the other times we've interacted, I've noticed a lot of times it's like weird things, excavators and pipes, and it's not always the technology that's like, it's usually not the technology that's the headache of the day. How is it different from what you anticipated, this startup and growing it and the challenges you have to face?
Right. Okay, well, I mean, it's not my first business.
Mm-hmm.
I've been entrepreneuring since I was in high school, and not all the business I've started have been passed on or shut down. Mm-hmm. So I actually have some other going concerns that, can occupy emergency moments, let's say. So you're talking about some of the plumbing and some of the water stuff that's going on around here. So on this land where Twente is occupying, we also supply the water and the sewage treatment for about 20 homes in this region. And so I lost a little bit of time this summer trying to stay on top of that a little bit. But we've got a big team now, so the focus on the 3D printing is still front and center for.
In a more macro perspective, though, is there any way you can kind of paint a picture for somebody who's like, oh, I'll start printing? How is it different from they anticipate?
It really depends on what background you come from. Honestly, I think everybody should start a 3D printing company. I'm not a very good marketer. I'm not going to say that everybody should just buy our printers. If our team was to quadruple in size and every other 3D printing company on the planet was to quadruple in size, we're not even remotely come close to supplying the need that the world has for 3D printers right now. So from that perspective, the competition's awesome. But the thing to anticipate probably is that there's a very strange and weird pushback from the really well-entrenched conservative mindsets that exist in construction, yes, but even more so in sort of the jurisdictional bodies such as municipalities or civil code or building code enforcers, let's say. They can be very smeagly about the way they behave with this new technology.
Yeah, it's interesting because it's limiting construction's innovation. It's the biggest industry in the world. And there's so much in place to keep things the way it is in terms of there's the permitting, but not only the permitting, the zoning. It's like, and then also a fire marshal might come in and shut a project down. There's so many angles from which, so many attack vectors. A big part as this industry grows, develops, there's going to be people trying to stand in the way, I imagine, as with any big change. Who are those people who would stand in the way of 3D printed construction?
Okay, it's really easy for us to be critical of these organizations. They have a very heady task, and that is to make sure that when buildings go up, they're safe for people to stay in, and beyond that, because the majority of families, their number one investment, their biggest asset they'll ever accumulate is not even a full ownership necessarily in their home, but like a partial ownership in their home through their mortgage strategies or what have you. And it's really hard on families when they go to sell a house and find out that the people who built it cut some corners and there's a bunch of mold or there's a bunch of non-compliant issues. So these people who are enforcing on the building code, they have a real task ahead of them. But the thing is there's like this a concept of just applying the rule for the sake of having the rule without actually understanding what's behind that rule. So to give a perfect example, like this beautiful home we're sitting in here right now, because we had already a commercial building permit application open. Like, we're net zero ready on this entire building, with exception to the doors, because the doors are these cheap retail doors that we're allowed to use. Because in the olden days, when there was a fire in a building, people would rush to the door, and the crowd pushing on the doors would prevent them from being able to open into the building. So it's like an anti-stampeding rule.
Just in case there's a stampede in here.
It's like, how can you have a stampede in a tiny home? Right? And we had these plans for these beautiful patio doors, sliding doors that would have had much better energy efficiency.
That's a perfect example of what you were talking about. Like these rules that just people are like checking these boxes and they don't understand why they're checking them. And
exactly.
It's tricky. Not everybody can make critical thinking on the fly.
They might not even be allowed to anymore. Let's see. I think that we're living in this era now where culpability and the insurance companies and the notion of, an individual decision maker being held accountable for something that could be extremely detrimental to them in the future makes it so nobody is using common sense. They're just applying the rule black and white.
I wonder if you could raise enough money and have your own insurance fund to insure your prints. I don't know.
Yeah, that's an interesting concept. I think that, we don't want to work outside the building code. Mm-hmm. We recognize the value in it. We want our buildings to be something that our clients can resell in the future. So we totally agree to adhering to the code. The question is whether or not the code can change quickly enough for some of the advancements that we're making. And I'm really proud to be part of the organization with ASTM, which is doing ISO standardization. Stefan Mansour, who you've interviewed in the past, he's been spearheading this great campaign. They have their meetings at this atrocious hour in the morning, so it's pretty easy to sleep through them. But they've got a pretty decent team putting together some concepts that will basically drive the building code to catch up to the technology.
ASTM section 52900. They're developing regulations, from my conversation with Stefan, from what I understand, correct me if I'm wrong, to be more of a guide and less of a restrictive, limiting kind of thing.
Yeah, so the language that we're starting with in that document is to try to keep things from the perspective of understanding that there's a massive amount of evolution that's going to go into this product,
which is so true,
process over the next few years, that they did not want to ram in some arbitrary rule that's going to be like a ghost in the system for decades to come, because a few of us with a little bit of experience said, oh, by the way, we should make this a rigid component of doing, for example, the qualification of your materials, when it may very well be that the material handling is going to change so much in the next 5 years that those prerequisite rules that we might write now based on today's knowledge will be nothing but a burden to the future people using this, trying to use this code to develop their own structures.
Yeah, and that's almost a guarantee, right? That the materials will change, parts of the systems will change and develop.
Mm-hmm. Well, the materials have to change. Everybody agrees that these companies are doing phenomenal work, but there's real issues in consistency. There's real issues in how the material performs in different environmental conditions. We've really taken on the task of having pumps and nozzle systems that allow for very on-the-fly adjustments to these variations that we see. But we've had projects that pretty much had to be canceled because the material provider couldn't guarantee a spec on the aggregate, for example, that was going to be in the material that made it. So the project basically had to stop or sideline, or they had to come up with new strategies because of the inconsistency that we were seeing in what was provided to us.
Yeah, Jim had mentioned you inverted your printer since the last time I was here, using your 9th axis.
I don't think so. I think when you were here last time, you looked at your footage.
Oh, it was inverted.
We were printing then upside down as well too.
I was going to ask, it has that 9th axis, so you anticipated from the start inverting it at some point potentially.
Oh yeah, it was always, we kind of had this romantic notion that somehow that we'd be able to have simultaneous 9th axis rotation on that. We just don't have a single print that's ever presented the need for that. And the programming language for that, with those SEW drives being driven by the ABB control system, it's such a heady task that the energy to get that to work is not. It's just not worth the effort. But indexing is very, very easy. So you stop the print, you do a controlled rotation, and then you start printing.
The circumstance where you might hypothetically invert mid-print might be if you wanted to print like on an angle above you or something?
Well, if you want to be printing above the printer's reach, then definitely you start with the printer in the upright position, with the robot in the upright position. But that dramatically reduces your overall width of your footprint, because now the beam that it's traveling on is its own obstruction. So you could conceivably start printing in the upright position, but then when you want to get wider, that you would swing down. But like as I said, we're going to do that as an index strategy for the time being. Simultaneous movement on that 9th axis it's just a waste of energy to try to make it work. However, it does lend to our Leonardo 2 system, which is, instead of the 9th axis being a rotational axis, it's a flying gantry style. So you can imagine, like I guess you've seen our Quebecinator and our Berlin printers, their standard 3-axis printer like everybody else has with rails on the ground. Now imagine a 6-axis robot hanging from that top Z position.
Yeah, get the best of both worlds.
Yeah, definitely. But again, it's very expensive machinery. The application case has to justify it.
So do you anticipate the Berlin outselling the Tillicum eventually, or is the Tillicum probably the high volume product?
It's funny. I think that the Berlin should be outselling the Tillicum. The thing is right now in the open market there are 50 or 60 other companies who produce Berlin-like machines. We're the only company in the world making a Tillicum type machine, so I think that's why the majority of our sales have been Tillicums right now. It's an excellent machine, but its application cases are very limited. We do have this really cool project where we're doing one Tillicum setup homes. I should actually go and grab you the model. The Tillicum machine is, what's really cool about it is it's very mobile and it's very versatile. So a lot of the stuff you saw printed around here that was printed in site, the Tillicum shows up, print, and we can move it at the end of the day.
Last time, what's the pricing on the Tillicum these days? I know it's probably changing depending on the supply chains and stuff.
It really depends, because there are, I guess different configurations. Our preference is to use the 6650S robot, which can reach down. The majority of our sales have been the 6700, pardon me. And those are coming in at around 315,000 euros.
When you say reach down, below grade?
It's just a style of robot. So, the ABB platform has got quite a few different reaching capacities and payload capacities. And the Tillicum is best served when it's sitting nice and high and is reaching down, so then you can reach up. And so, doing 3.5-4 meter prints is not a big challenge.
I noticed your nozzle head used to be straight pipe, now it has, I don't know if you would call it an elbow joint or it's like a double elbow joint.
Oh, we have a variety of nozzles for different reasons, different application cases. So the straight, what we call the musket, it's got a little bit of an opening to it. That will be for objects where you're going to build 2.5D style. You're not necessarily going to be reaching too close to things. We put the curve in when, say, we need to get up really close to another print. So if you look at some of the footage of the flower beds we did over next to the glass house there, in order to be able to reach really close to a previously printed wall, you've got that. And then, of course, we've got other application cases where we might want to have the nozzle have different shapes for the different type of bead qualities we want to go for.
Well, how do you decide the layer height?
That's in the programming side of it. The guys will try to determine how do we make this into an 8-hour workday, how do we build quickly but not have too much potential for disruption in the actual print itself. The smaller the bead thickness is, the better back pressure you get on your hose, the more consistent your bead is. But of course your build rate is slower and you have more joints and you have the chance for it's like anything, the more of anything, the higher percentage of chance that you're going to have a failure. So if you're going to have a failed print if you're going to have a clog in 1 kilometer or 1.5 kilometers of bead, the idea is that like the Tillicum as a mobile printer can very quickly and rapidly deploy houses. And the notion of the one-day house is something that a lot of 3D printing companies have been putting out there as being this realistic thing that can happen. And it's true, it absolutely can happen, but there's often a lot of steps that are being left out. And we thought that if we really wanted to have an impact on the affordable housing industry, and if we wanted to have an impact on, like, there's a refugee crisis going on obviously all over Europe right now. We've had some huge forest fires and floods here in British Columbia, so we get lots of requests to help with affordable housing. and to do it quickly. And so we came up with this concept of basically doing the printed elements in one day, but that includes the setup of the printer and the teardown of the printer.
You say one-day house, but I want to clarify. There's a caveat. Many people have seen house printed in 12 hours, house printed in 24 hours. Some of those same houses that I've seen those claims on, I have videos of their progress over 6 months, where they have 6 inches done, and then I come back in 3 months, they have a few feet, and they're like 12-hour prints. Like, okay, what's going on here? And they're not liars. They're talking about the print time of when they were extruding material. And so if you consider the caveat and you listen really closely, they're being honest, but it's very different from a house built in a day, like you're describing.
Right. And just to be clear, we're only planning on doing the extruded concrete in a day. All the other elements are going to be up to the other contract.
But all the printing in one day, not over 6 months.
So what we did is we designed this house, and basically this is just the first of many pods that we're going to do. The Keiko is a 55 square meter house, or just over 570 square feet. But what makes it unique is that you pull the Tillicum in. You can imagine the Tillicum pulls in, and we'll just show it upside down. And this actually shows the tool path everywhere that it does. So you've got your inside wall, your outside wall. You've got your 4 columns that will actually support your beams. Then you've also got your shear walls that will also be filled with concrete and rebar, so that's to deal with your racking issues. And then everything else is going to be, conventional contracting. So the roof structure, the beams themselves will be cross-laminate timber. But what's unique is you've got this huge opening here, and then that ends up being a curtain wall, or glazing as some people call it. And then the printer can just pull out, it can park next door, and it can start printing the next one.
Sure.
Start printing the next one. And so this is kind of like the basic concept of really rapidly deploy housing using our mobile printer. And our mobile printer, you can just pull it with a 1-ton truck. There's no special transport requirements. You don't need a crane or anything to set it up. We really can extrude the skeleton of a house easily in a day. And
you could adjust the thickness between the walls to change the R value, whatever.
Well, this is already a 30 centimeter gap we're doing here. So this is going to be pretty close to net zero ready, depending on what they spec for their windows, and of course what their roof structure is going to be. But your windows, doors, and everything, if they are in that same energy class, solar panels on top of that with a geothermal pump or something like that, and this thing may not consume any external energy at all, conceivably. So that was the idea behind this design. And this is just the beginning to mention. We're going to have a catalog. You're going to be able to go onto our website and basically order a house, and instead of it being just a philosophical thing, we'll say, yeah, we've got Citizen Robotics, they've got a Tillicum, they can come do it for you, or we've got other people in the United States that will be receiving printers this year, people receiving printers in Japan. They can take that drawing set, go and get their building permit, and then when they're ready, we can show up and we can print it. So
I'd love to stop by Citizen Robotics facility if they'd be willing to let me do a video with them. We'll see.
Yeah, sure. Tom's a really nice guy. They got an awesome team there.
The last time I asked, he kind of was not ready yet or something.
Yeah. Well, there's one thing that everybody really has to understand about this is you don't go and buy a brand new piece of equipment without having any clue how it works. And so when we sell machinery, we sell them first on the concept of being ready to learn about the complexities around 3D printing. This is not just pulling out an app and pushing play. There is a massive amount of learning that needs to be done. So the idea that you have people not ready to see you, Jarrett, is because they want to make sure that they got things tied up.
Something I've always really appreciated about the way you run your business is that you don't try to influence the content I'm making at all. And like when stuff goes bad, you're not trying to hide flaws. And every company, you have stuff your company's working on that's under development that you'll release in the future. But it's other companies, a print will go wrong, or they'll run into a problem and they'll be like, please turn the camera off. You've never done anything like that. And so it's a level of authenticity that I think the other companies could benefit from having too, if they were willing to show people the getting started process and learning. I'm in a new region now. How do I dial in my material to function well in this region? It's like people only want to go and show people when they have it dialed in, it's all ready to go. And even then, it's not dialed in because it's a technology, right? It's always under development in the...
But, I mean, okay, there is definitely a culture of people trying to hide things. But if you went onto our website when we first founded, you would have saw a statement on there that says that, you know, you see furthest when you're sitting on the shoulders of giants. Mm-hmm. And Twente could not have possibly been where it is had, you know, Henrik from Cobalt not invited us to come and see what he was doing. And Volker from Vertigo was a huge influence on helping us to decide, you know, what track we should be going down. You know, these, like, look at how much Baumet has had an influence on the way we do our motion control.
We were talking about you and Jim started off building a gantry system. At what point did you realize we got to put a robotic arm on this thing?
Oh, okay. But Jim and I, when we built that first gantry system, that was for cutting molds for making skateboards.
Mm-hmm. CNC.
Like ages ago. Yes, ages ago. So it's a really well-known technology that's been around for a long time. I think it's funny. So Nikita from Apuscore has been, I would say, arguably trolling the industry lately by putting how to make gantry system plans on his LinkedIn and Facebook page, which I think is funny. It's pretty tongue-in-cheek. I hope he's not bitter with people who are, you know, competing in this space, but it's true. Like, so anybody can jump into this if they want to. The thing that we're trying to do is to take that initial step that everyone's leaping into and go through all of the headaches and try to come up with programming choices, nozzle choices, pump and water and mix choices, and add that technology to the way we put our systems together so that when people buy a machine from us, they're already sitting on our shoulders, if you want to use that expression again, and the 4 years of mistakes we've made, and they don't have to make them now, at least not as many of them. You walk around the site, you can see we're trying to print the hardest, craziest stuff that anybody's ever printed before, not because it's necessarily the right application case, but if somebody's not pushing this technology to its limits, nobody would know what the limits are.
Yeah, and this house is a great example of that, where other people have conformed to existing construction methods. You really did experiment with something new that hasn't been done, and it's like, I've been saying it's the 3D printed house for printers of houses, because it's something that anybody who prints a house, I think, will appreciate, rather than trying to make it look like something people have seen before. You made something new.
Yeah, obviously, you know, we really gave ourselves a challenge with this one. We wanted to make it difficult for ourselves because that's kind of the nature of making something, you know, grow or expand technically. We do get an enormous amount of, we like to call them tire kickers, because you know, we get hundreds of requests a week. We get sent dozens of drawings a week about can you please cost out printing this house in. And then they send it to us, and it's like a square rectangular building with a conventional triangular truss, and it's the houses they've all seen many times before. It's the ones that have got architectural drawings for. The thing that's really strange about that notion, like, and I give this, I'm probably starting to sound like a broken record on this one, but you know, if you call up John Deere or Caterpillar, who sell excavators, and you say, okay, I'm looking at your 5-ton machine. How much is it going to cost me to dig a hole that's 200 meters wide, 1 meter deep?
It's about the amount of data. There's not enough data points yet.
But that's never anything anyone would ever ask those guys. They will say,
True.
Our excavator's got a lifting capacity of this. We can put it on a truck of this size. This is how much it costs. People call up 3D printer makers and say, I would like you to tell me how much it's going to cost to make this house in this jurisdiction with this material. And you know nothing about what they're building.
You pay for an excavator on a day rate, so it's quite different. The material is an expensive part of the process, so there's a much bigger variable cost than a piece of equipment like most of the...
Okay, but Jerry, I don't sell material. We don't sell materials. And, you know, John Deere and Caterpillar, they don't sell holes.
Yeah, I mean, the point is the customers are asking questions that haven't been answered yet because it hasn't been tried yet in their region, so that there's no way to give a good estimate.
Exactly.
I run into the same problem.
It shouldn't be on us to know what local laborer is in Bangladesh or in Brazil.
And even if it was, how could you possibly? I mean, there's no construction estimator that gets within 10% regularly. I mean,
but we do it all the time. Every week, we try our best to look at someone's drawings, try to do the volumetric calculations of how much concrete it's going to take to print that building, give a basic estimate. We've got a cost calculator. We send it to them. Say, okay, you put in your own cost of windows, your own cost of flooring, plumbing, all this stuff, and maybe you'll kind of have an idea how much it's going to cost.
And then they say, what? We thought this was $4,000.
Yeah, they do. But the reality is that there's a very small people in the construction world that would be naive enough to believe that that's a real number.
Exactly.
Yeah.
It's like the roof costs $4,000. The windows cost $4,000. The slab costs $10,000.
Yeah.
How are you building a house for $4,000?
Yeah.
What land?
Yeah. But there might be truth. So all the concrete in this building costs $6,000. And if we were to even just use like a keystoning practice, we would maybe build it to a job at $12,000.
Are you able to disclose the total cost of this?
Yeah, so all in, we figure the house came out, and this is because we made estimations on our own labor. It costs about $120,000 Canadian, or roughly $100,000 US. And when you look at that number, we think we probably could knock 20% of it on our next version of this, because we did so many things here, we had no idea what we were getting ourselves into when we got started. You have to understand, Twente first is an automation company, is a machine building company. There's some construction savvy in the company from guys who've had a little bit of experience working in that field, but nobody ever ran a construction company. Nobody ever built houses from start to finish prior to us getting involved in this. And so some of the decisions we made were maybe made on the fly. We're not necessarily in anticipation of some of the complications we would have had around working with the printed concrete.
I've consistently seen companies save between 15 and 30% from their first house to their second house, only on auxiliary costs, not the... sometimes the second house is significantly larger, taller, whatever it is, but they learn so much from house 1 to house 2.
Yeah. So this house here, this Keiko, is going to be about double the square footage of this one, and should come in at an overall cost of about the same. So that's almost a 50% cost reduction.
Yeah.
And the reason is because we don't have any craning on this one, but everything we learned about the preparation, site preparation, is considered. There's an enormous amount of new knowledge in this space that hasn't been acquired by any of the companies yet, and we're in that space right now where we're trying to experiment and push the boundaries so that new knowledge can be there and shared, and guys like you coming to ask the questions that'll make it so people understand what they're getting into.
What good kind of catalysts would help you expand and scale faster? How could you grow the fastest right now?
We're in a funny space right now because we are living from sale to sale. We are an operational company first. We have not gone out to the open market for large rounds of funding. I think arguably we're foolish not to. At some point, we definitely need to be operating in the same space. Those guys at Icon have done a phenomenal job of getting investors excited, Mighty Buildings. Even those guys at Diamond Age, who've never really actually made anything as far as I can tell, have managed to get investors excited about some of the stuff they want to work on. And it would behoove us to not capitalize now when there's excitement around this. But the thing is I've been running operations and companies for many, many years. To me, the most important thing is to run a profitable business, to develop technology with an R&D strategy that is the least amount of money to go in to create a product that can be scaled quickly. But we have awesome investment strategies in that we are opening up subsidiaries. So we've got the Dubai subsidiary. Hopefully within 2 months our Indonesian subsidiary will be open, which will actually be operating both in Jakarta and on Bali. And the relationships we have with the investors we have so far are all friends and family or else associated businesses. So either suppliers or customers who liked what we're doing and they wanted to get in. And so we've sort of allowed them in at that level. But it would definitely be nice to have the war chest.
So let's say, skip a couple steps. You raise, I guess the ideal amount would be somewhere between 10 and 100 million. What would the use be? Like, where would you go after that?
Okay, so the business models I build don't start with a number first and then decide what I would do with it. I've actually built a very flushed out operational plan for our global operations that calls for somewhere between 40 and 50 million worth of investment. That's to reach operational profit within a desired time frame that is under the kind of conventional business standards. There is no, speculation or assumed future valuation in that strategy. which is not the thing that gets the investors excited. They would rather see, okay, we're going to put 100 million in. When do we get our 5x? And that's something that you have to start making up numbers, and you have to start pretending you know the future.
10% cash flow would be pretty good.
Well, there's a really, cash flow is a humongous thing, because what people don't seem to ever recognize is that your supply chain cash flow is hugely impacted by the types of terms you can negotiate with the people who are providing your goods. And even if you do get favorable payment terms on some of your supplies, there's also the notion that your collections is also going to be something you can do in a meaningful time frame. So when I build my models, I'm not just looking at what our sales are going to be and what our cost of goods sold. Well, I've got a way that I can change it in my planning. So if you are imagining that you're going to do X number of sales, the percentage of the collection of those sales in the first 30 days may only be 30 to 50%. Mm-hmm. If that's not in your cash flow modeling, you can easily be in a great business, a profitable business, but yet you still don't have the liquidity to keep things going. We love working with ABB, KUKA. We haven't tried any other robot companies yet. It might be that we're working with some other robot companies, but they almost all demand a fairly large amount of money up front. And then they can turn around and take 24, 26 weeks to deliver the goods. And so how do you justify with your client that, they're going to have to give you a deposit, so you can give your robot supplier a deposit, and then everybody sits around and waits, or everybody sits around and pays interest on that? So that game is something that's not mature in this industry yet, and we have to get to the point where we've got long-term supply agreements with our component suppliers, and that we are able to manage the collections on our end so that our sales are actually arriving, the revenues from sales are arriving in time.
A war chest to really secure those long-term contracts.
Yeah, you can. That is a strategy, to just sit on a large amount of cash. But cash that's not earning for your investors is also something that's not very good either. So you kind of want to make sure that you only borrow the exact amount you need. Mm-hmm. And so the business model that I think that this space that we want to operate in right now, for us to get to the expansion we're looking at, is somewhere between 40 and 60 million. Mm-hmm. In euros. I tend to work mostly in euros when I'm discussing these things. And what that does is that allows all of our subsidiaries to get a little bit of a ramp up in their R&D equipment, and then also be able to have their sales and their technical team available for their regional support. I think that's kind of the main thing. But that's a very abstract number that is something that you can pick holes in if you're like.
Would that number give you like 24/7 support for your clients?
We already have 24/7 support. The sun doesn't set on Twente right now. We've got operations in Dubai, and we've got operations in Europe. We've got operations in North America, and like I said, we're within a couple months away of having a permanent operation in Indonesia.
Yeah, I'd say 24/7 support is huge, because there are companies who say we will not take a call after 2 p.m. EST. Mm-hmm. So if you're on a construction site, especially with the time restrictions, sometimes the temperature of printing, you want specific parameters. So if you're waiting for the afternoon to get a nice print going or something, and the country that you're trying to communicate with won't respond, that's money down the drain.
Yeah, well, it's not just money down the drain, it's frustration for your client. And the most sales we've achieved so far has not been because of our own initial sales. It's because of the people that we've had great contracts with, telling their colleagues and friends or associated businesses, working with Twente has been a real pleasure. Those guys are there for us, and then that leads to more sales. And that really comes from that service point that you're talking about.
The team behind the printer is such an important part of the process, because it's a evolution. And I always try to look more at the work the team's doing to make stuff better, because that's, I think, the best teller of like 20 years from now who's dominating the 3D printed construction industry. Yep. It's like your best guess is whoever's innovating, whoever's changing stuff. And
so we call them subsidiaries on paper, but in reality, all these individual locations we have, they're all R&D facilities. Mm-hmm. And it's not that they're only doing R&D there. They're definitely all doing sales support, and they're building machines and selling machines and running prints. We do offer the service of printing as a billable that we do. The engineering around designing prints, this is all in our wheelhouse. But the notion that they're all our research and development facilities means that there's something new going on in all those locations, and then that information basically trickles up to the engineers in the Netherlands, and then gets disseminated back out to the rest of the teams elsewhere in the world. So.
And that'll continue. I mean, anybody that buys a printer is probably the first in their at least state or town. Their neighbors are going to say, what do you have going on here? And,
So for example, like we're printing barracks for the U.S. Air Force in Dubai.
Awesome.
And the thing that they came at us was, we need to see the rebar in the ground first, because they got a complex rebar structure. So we have to print around the rebar.
You built the longest TCB extension in the world?
Okay, so tool center point is the translation spot that your robot tells all of its motion to be based upon. And we think we broke the record for the longest TCP of any robot with this one that we did in Dubai for this U.S. Air Force barracks project.
What was the length?
I think it's 3.5 meters onto a 3 meter arm, so it's like a 6.5 meter TCP. I'll give you some pictures of it. You get a kick out of it. And
comment below if you could top that.
Yeah, or if it's been beat by somebody else, we'd like to know. You don't really know, but definitely what we're doing with robots is we're pushing them to levels that the manufacturers of robots have never imagined. Right? They're used to robots being used in discrete manufacturing, whereas we're sending thousands and thousands of lines of code.
I think that same principle applies to the printers you're building. Like, people will use them in ways you never imagined.
I hope so.
Your customers.
I hope so. And we don't actually really find ourselves to be incredibly creative. We think that we are inspired by a lot of the things we've already seen out there, and we're just trying to make improvements on it. When they're really, really cool, like architect minds or builders or crafters that are out there get their hands on these things, then you're going to start seeing some amazing stuff.
It takes all kinds of like mistakes and falls and accidents to really figure out all the cool design efficiencies. And has there ever been a unexpected improvement that came from somewhere that wasn't linear?
Okay, so we've got a very diverse engineering team. So our head of research and development is Tim, who you've met. He's a very pragmatic Bavarian
in Germany.
And has this concept of plan first, make sure you get the result that you thought you were going to get, and if you didn't get that result, do an analysis of why you didn't get that result. And he's a really good coach for the rest of us who are much more prone to, hey, what if we try this? What if we try that? And we might burn through some material or break a few things. But the yin and the yang of the creative style that we have is actually like this full circle of product evolution at the print level and also at the machine level. Both those things are evolving because of that approach. We've got these two young engineers from the Netherlands who are contributing hugely in being able to focus, like drilling down on very specific articulation issues we're having in some of the stuff we've been working on. So, when you got a small team and 100 projects, you got 1/100th of their time in each project. And when you have these younger guys working on just very specific things, then they can come up with some very fast advancement. So it's
cool
really a bit of a mix of all that we got going on right now.
Maybe a competition one day, if you have an extra day of printing, like have students compete to create some design or something. Just explore the different possibilities.
Well, we actually already did that here. So it's not online anymore, but we had a site where you could actually go in and you could make vases and flower pots and different types of things, and you could use the parametric tools that were on the website.
I think that's too limited. You have to do one that's like open submission, and people submit stuff that is terrible, can't be printed, requires tons of sorting through.
It was used for them as an inspiration, and so then they went back to their own CAD software. And this is through the Selkirk College STACK program. And then we chose one or two of the designs that we thought were the best. They brought the whole school here. We had like all 30 of them lined up in the shop there, and we printed off the two winners that we thought.
That's awesome. Some of those kids will probably be the future of the 3D printed construction.
Yeah, we hope so. We took on one intern out of that group right away, and then obviously when there's room for more guys out here, we'll be picking up from that program for sure.
People need hands-on exposure. Like, you can watch a million YouTube videos, but there's something different, the learning that you get when you're doing something, and like it's challenging. So many people see a 3D printed house, they think it's an app, you just press go, but there is, and it's not, every company has a manual effort to make the print happen, whether they're manually designing the project or once they get on site, manually dialing in the mixture, like, what's the app that you just press play?
There isn't one. That doesn't exist. I think what exists is the next generation who's ready for an app like that to exist, and so they're going to do the hard work to get to the point where this easy automation is going to be much more readily available to people who want it.
I believe it's possible that it could be an app, whether it's in my lifetime or...
You sat with Cameron, for example. Fresh out of school, has got some new ideas. Yost, he's also here. And, the world that they grew up in, because, they're in their early 20s, the things that we took for granted, for them is just a standard, And wait a second, I got that wrong. The things that they take for granted is now a standard that wasn't for us. Mm-hmm. And the notion that an app that can print a house is not a huge leap, right? That's something that we giggle about it. It sounds silly, but to that generation, it's something that they can totally conceive. And the thing is everything about what we're doing can be automated eventually. This table that's sitting here, of course, Kirk put in the hours to get it sanded and put nice, but the leg was 3D printed. And the time it took to program and print the leg
this is local
was a
wood, right?
fraction of the time it took to get this nice. Speaking of Cam, he's walking around out there, and Jim, they can lurk in the windows here.
Come in. Or no? I don't know. Should they join us and close it out that way?
Sure, if they want to.
You guys join us and close out the podcast.
We were just talking about you, Cam. That's hilarious.
Oh, really? Awesome.
Yeah. We're talking about how much he complains, how much he pisses and moans about having to climb ladders.
Yeah. I don't like climbing ladders, I'll give you that one.
No, we were just basically saying how, the generation that Jim and I grew up in, the things you guys take for granted for us wasn't even necessarily something we thought possible. And, Jared is asking if there's ever going to be a print home app on your phone. And you can imagine that existing, right?
Oh yeah, of course. Hopefully I'll see it in my lifetime too.
Yeah.
I really hope to.
I don't think he's on camera, the way. I'll turn that. I'm going to be the cameraman there.
I don't know if you guys want my feet so close. Yeah, of course.
They smell.
Yeah, do they?
We have 100,000 people on live right now.
Really?
Oh.
No, I'm just kidding.
No,
So that's hard work.
Right?
Yeah.
And not complaining. That's where the stinky feet come from.
Yeah.
But no, I totally picture that if you could just select a house, what would be better than that? Or even order one. You go online and you go to Twente and you say, I want this one until it comes shows up without even a word spoken, and your house is there 4 days later.
What do you guys think of being your boss?
Oh, I love working for the guy.
Yeah.
Never met anyone like
Best
anyone
job
here at Twente.
I like working with you guys. It's awesome. You guys let me film whatever. You don't put any restrictions on me, and it's awesome being here in Canada. You guys should definitely reach out to the 20 crew, and I'm sure they'd love to talk to you if you're a serious 3D printed construction individual.
For any 3D printing, any additive manufacturing, it's still cool. It's worth looking into. And I'm sure all of us are here to answer questions for anyone.
If somebody wants to reach out, what's the best way for them to get you?
JIMZ@twente-am.com.
Instagram too, Twente Additive Manufacturing Instagram. Answer DMs as well.
I'm still using smoke signals, so just blanket over the fire.
Ian's had the same phone number for 25 years now. So.
All right. Well, thank you guys for having me. It's been a pleasure.
Thanks for coming. It's been a pleasure to have you again. Keep seeing you all over the place, eh?